Do I know any examples in the modern world of plant communities that go from water to land and show that transition with different types of plants right next to each other? And I thought, yes, there is one thing I know of that does that. In my experience, I had this amazing experience as a 12-year-old. I was taken to a quaking bog. Now, how many of you have been to and walked on a quaking bog? That's what one person. And that person has been in the north. Okay? There ain't no quaking bogs south of the Ohio River. This is a phenomenon of glacial terrain in North America. Really exciting. Here's what happened. I got out of the car. Several of us kids with our field trip leader got out of the car, and we walked up a steep hill and then down another steep hill and walked up another steep hill and another steep hill. Really steep. These were actually old sand dunes that forests had grown on. So they're extremely steep, about 200 feet high, and then down the other side the same. And I were like, and all of a sudden, and it was quite sudden, the trail got very flat. That's odd. It had been very, very steep, and now it's very, very flat. We go out about 200 yards into that flat area, and our leader says, okay, let's stop right here. Let's all hold hands. What's going on out here in the woods? So we get in this big circle, and we all stand out there holding hands, and I'm very dubious here. And he says, okay, now everyone, we're going to jump up in the air and jump back down again, get into sync with each other. That took a while. 12-year-old kids to jump up and down at the same time. Yeah, right. Okay, it took a while before we finally were getting, and I realized, wait a minute, this is weird. When I jumped up and came down, your brain's able to do some amazing things. It actually can locate yourself in vertical space. And I realized, wait a minute, I should be touching ground. I'm not. And I hit the ground lower than I left it. And then I noticed that as I leaped off, the ground was coming up as I was coming up. I'm thinking, oh, I'm losing it. But looking then at the whole situation, we now got into a nice pattern here. We realized the ground was in fact producing waves around us. There were deformations of the ground in circular waves that were moving through the forest away from us. And as the wave in the ground got to a plant would be sitting here like this, and the first wave would get there and it would turn like this and then turn like that as the wave went through the plant. And it even got to trees, and we were swaying. Trees that are a foot in diameter. Like, whoa! And I began to realize we're on water. This is a vegetation mat on the surface of water, thick enough that we don't fall through, and yet thin enough that we can actually create waves in the vegetation mat as the waves move across the surface of the water. Blow my mind. Okay. Sorry, I just 12-year-old. Yeah. And we walked out from there, and things got really exciting because the mat gets thinner and thinner and thinner until we're afraid we're going to fall through. We're crawling on our hands and knees, and there's these pitcher plants and sundew plants right there in our face. It's like cool stuff. And then eventually gets out to open water. Here's the situation with a bog. According to theory, a lake forms in a given region. Then plants start growing out on the lake from the shore towards the center of the lake, on the surface of the lake. Next. In time, it supports first sedges and reeds, then taller bushes, then a full forest. This is an aerial photo of the last bog, quaking bog, left in the state of Illinois, Volo Bog. The only part of water is a very small amount in the very center, well, not quite center, in the upper center of the lake. But if you go out on that lake, the plants really are floating on the water. Next. They eventually fill the entire lake. So we're having fewer and fewer quaking bogs with time. Next. Now here, to prove to you this is really true, Out on Bolo Bog, I'm taking some videos. Here's some ferns there. I mean, there's a floating sidewalk that we're walking on, and I'm photographing. Here's some cattails. It's just mind-blowing. It's really hard to believe unless you're actually there. And here's my favorite. It's the only tree I could reach from the sidewalk. It's about 3-4 inches in diameter. I'm actually able to, but there's some big trees that would do the same thing, but I'd have to, fall off the sidewalk and get in trouble. So I didn't do that. Next. So the idea is that at first, or out on the edge of this bog, we've got open water. Then we've got a fascinating section of it where there's a false bottom. It looks like there's a bottom, like that tadpole looks like it's on the bottom, but it isn't. Put your hand through it quite readily. And then there's an area where you got sedges and reeds. Then you got short bushes. Then you got tall bushes. And finally, in the oldest part of the bog, you have a tree zone. Now, one thing that I recognized is this increasing size of plants. And next, one thing I remembered about the fossil record of plants is they also increase in size as you go up the sequence. So now we've got an ecological order, we've got an increasing size order. So let's turn the little puppy on its side and build a floating bog from the plants. Just literally take the earliest plants, put them out at the edge. The latest plants, put them in the oldest part of the thing. And considering how many plants we're talking about across the entire world, and it producing all of the coal of the world, this is not just a little bog and a little lake. This is a forest the size of a major continent floating on the oceans of the pre-flood world. So we reconstruct the forest. Next. When the flood comes, the flood would rip this thing apart. Big waves would begin to tear the forest apart from the outside towards the middle. The middle is the stablest. It's going to last the longest in the catastrophe of the flood. But the edges are going to get destroyed first. They're going to filter down to the bottom next. And they're going to drop the plants down there at the first. And then as time goes on, it will eventually destroy all the plants of the forest. In this process, this explains several things that we see in the fossil record. First of all, the water-to-land order. It would explain that evolution explains. Secondly, it explains the increasing size of plants. Thirdly, it explains why these plants are almost all extinct. Because if this was destroyed in the flood, it had never able to regrow after the flood. The ocean is too rough for this to regrow on the ocean. God could have created the forest in place, but once it's destroyed, it would have to be recreated in its entirety. It can never grow out onto the ocean again. So it explains why these plants are near extinct. It also explains another problem that I have always had with it. I'm finding these fossil ferns, fossil plants, in marine sediments, in saltwater sediments. This is not where you find plants living today, okay? And so that was always kind of weird, but it makes sense that this floating forest, when it was destroyed, is dropping material down to the bottom of the ocean because it's Noah's flood that is taking it out. Also, it explains another interesting feature of the trees. The trees in this forest are hollow. Weird. Got big trees, 3.5, 4 feet in diameter. They're hollow. The branches are hollow. The twigs are hollow. Almost every species in this whole thing is hollow. Weird. Why? Well, actually, a floating forest makes sense. It makes the trees lighter. We're used to trees that are solid in the middle. Yeah, they can float, but it would be even better, lighter, if they could, in fact, be hollow. And in fact, although we don't have trees in the present that are hollow, the plants that are hollow in the same way are small plants, and they're all aquatic floating plants in the present world. Furthermore, there's some weird roots on these things. The roots are rather large roots with tiny little rootlets that come out that are very flexible. This is not the sort of thing to grow through soil. But it is the sort of thing that if they intertwined their roots, held themselves up by the intertwining of their roots, and sent out flexible roots into the water, it's something that anatomically makes sense. And in fact, the few plants that have these kinds of roots in the present are aquatic floating plants. So this theory that there was, in fact, before the flood, a continent-sized floating forest that was destroyed in the flood explains a number of features of the fossil record of plants. Furthermore, it explains the fish-to-amphibian sequence. Evolutionists will point to the fact the oldest animals with vertebrae, with bones, are in fact fish. Then we've got amphibians. In fact, we've got a half amphibians, half fish. We've got these critters that look like they can swim like fish, but they've got legs. Okay, why are they swimming like fish and have legs? And then we have amphibians that have legs and walk on land, and then we have reptiles. Well, this makes sense. See, when we're out here way at the edge, like I was when I was crawling on my hands and knees out near the edge of that, I'm afraid I'm going to fall through. It's not a good thing to be a vertical walker on the edge of this very thin mat. What's best is to actually be able to swim in water, run along on the bottom of the mat. You're not putting any weight on the mat, so you're not going to fall through the mat. And so specially designed organisms, God's designed special organisms for the edge of that mat, they're going to get buried there as the first land animals in this burial sequence. And thus, we got fish buried first out there, and then we've got the half fish, half amphibian kind of things on the edge of the mat. Then we've got full-fledged amphibians and reptiles in the middle of the mat. So it actually explains the evolutionary sequence of the transition, the evolutionary transition supposedly, between sea creatures and land creatures. Next. Where am I at time? Oh, not doing too bad. I've only got 3 hours to go, and I'm going to make it. Furthermore, it goes further. This gets exciting. This gets even more exciting. I get excited when a theory, you're not, but I get excited when a theory actually explains a lot more than you created it for. I created it to explain the order, that first thing over there, water to land order of Paleozoic plants. That's what I created it to explain. But all of a sudden, when I realized what I had, it explains all these things. And it explains coal, because it turns out coal is found in the fossil record where these last plants are found. In fact, the coal that you're most familiar with, there's 3 major types of coal in the world. The type of coal you've benefited from because it's being consumed all the time is the type that's made from the plants that are on the right side of this diagram. But the coal has always been observed to be rather strange. It's hard to explain in the conventional understanding of the origin of coal. Conventionally, it's understood that coal is formed in a swamp. Trees grow up, they drop their leaves and branches and stuff down to the floor of the swamp, and something prevents those things from being decomposed, and they accumulate a whole bunch of plant material. That plant material will eventually be formed into coal. The problem with these kind of explanations, several problems here. One, in the evolutionary scenario, that coal existed about 300 million years ago. If it did exist 300 million years ago, it shouldn't have any carbon-14 left in it. We lose our carbon-14 in about 50,000 years. So if these things are really that old, there should be no C14 in them. But alas, every coal chunk that we've investigated has C14 in it, indicating that it's only thousands of years old, not millions, certainly not tens of millions, and especially not 300 million years old. So this scenario, since the flood only occurred about 4,500 years ago, fits the fact that we've got C14 in the coal. In addition, the coal turns out to be made of chunks of bark. In fact, recognizable when you get in there and look at the coal, pieces of bark about the size of dinner plates, rather common Well, if you go into swamps and look at the kind of plant material you find in swamps, you don't find dinner-sized pieces of bark or any plant material that size. It gets broken up into small, sort of coffee grounds kind of consistency. You don't find recognizable pieces of organic matter in it. But this coal has lots of recognizable pieces of organic matter. That makes sense if you've got the plants up above in the floating forest are getting ripped apart. The bark is being peeled off of these logs as they turn against one another. The pieces of bark float down to the bottom and get accumulated on the bottom. The coal then is going to be made of bark. In fact, I told you these plants are hollow, so actually all they are is bark. It's just bark, okay? Bark, bark, bark. And then the bark accumulates down the bottom. That's what the coal is made of. And that's been a mystery to those who study coal as to why these recognizable chunks of bark are there. But this theory, in fact, explains that. Also, another problem is that coal seams, when you see them in the field, are very often got a nice flat surface on the bottom, nice flat surface on the top, and often they have what they call a bench, a section in the middle of the coal seam that isn't coal, it's something else. It's usually a marine shale in the middle of it. It might only be an inch thick, but it can be traced across counties. How do you explain these things? The problem with the conventional method explanation, we got trees dropping stuff down, is these trees have roots. So if you've got a layer of coal, you should have evidence of roots beneath it, because the trees that produce the coal, that produce this vegetable material, should be reaching down underneath that layer of debris that's been accumulated and make at least that boundary between coal and non-coal non-uniform. Should be able to find roots, and it should be a non-uniform, but in fact, that's not what you find. You find flat boundaries and no roots in the underlying sediments. But this theory explains that, because you've got a floating forest that's been destroyed. There's just a bunch of logs up there that are being destroyed by rolling up against one another. This stuff floats down to the bottom, lays on the bottom, on a flat bottom. You got a sudden transition between mud and coal. Then the floating forest blows off to the side over here. Some mud comes in. Then the forest floats back over the top and continues that deposition. So you can get just maybe 1 inch of mud in the middle of your coal. But that doesn't make sense if you're trying to build a forest. You build a forest and then a mud layer comes in. You've got to regrow trees. Surely trees are going to destroy 1 inch of mud and mess it up. But you got this uniform mud layer. So the mud layers of these benches are explained by this theory. The flat tops of the coal is explained. The fact that in coal measures, like in Illinois where we find a lot of coal, we'll find 120 different coal seams. The fact that this forest, as it's being ruined, is being blown back and forth across an area, you're going to have a coal seam deposited. Then after a bit of time, it comes back again, and another coal seam is deposited back and forth. And it explains why we have many, many coal layers in a given coal measure. Something that's extraordinarily difficult to explain in terms of here's a swamp that was generated for 50,000 years, and then a million years later, another swamp of the same trees, the exact same trees, and the exact same species of plants and animals, all the way through the entire coal seam. That's another thing that's weird here. We have the same trees over 100 million years of time, if evolution is true. Unchanging. That doesn't make much sense in evolutionary theory. It's explained by this. Let's see. The fact that these coal seams can be found across states and, in fact, continents. The Carboniferous coal seams are found from Missouri all the way across New York and continuing on to Europe, across Europe into Russia. The exact same trees, exact same plants, exact same animals across that entire region. You can trace these coal seams hundreds to even thousands of miles. That makes no sense. That's an enormous swamp that is persisting over absurd lengths of time, if in fact the conventional or evolutionary explanation is true. The enormous biomass of coal. There's a lot of coal out there. We've been burning coal at an enormous rate for a very long time. It indicates that there was an enormous biomass in the past. There's much more organic matter in organisms sometime in the past than there is now. And this would be explained by a continent-sized forest. Next. So, back to the beginning. Evolution explains a lot. It really does. Evolution said that the plants, here's the evolutionary claim with respect to plants, plants appeared in the order that evolution generated them. Evolutionist claims that plants evolved, and they did so over hundreds of millions of years, and the fossil record proves it. Well, it is in fact true that the fossil record does show the water-to-land order of Paleozoic plants expected by evolution. Good job, evolution. Doing good. It actually doesn't explain the increasing size of Paleozoic plants, too, because if you look into the design necessary to produce a tree as opposed to a short little plant, amazing design is required. I mean, if evolution is producing this, it's going to take a long time to generate a tree. And so it makes sense that the first things are small, and then it only later that you get the big things. It also explains why these plants are nearly extinct, because they evolved a very long time ago, and they've just gone extinct. It's what happens, you know. Certain family names go out of existence merely because people just happen to die in that family, or they all have girls, and so they lose their names. And I mean, that's just the way it happens. So you would expect after 300 million years, you'd lose most of these plants. It also explains the fish-to-amphibian sequence. You know, you don't need to deny the explanatory power of evolution. It does a great job, and it does explain a lot. Unfortunately for them, next, there's more explained by the Bible. It comes as simple as that. Here's a theory. You see, back up one. If I was an evolutionist, looking at the fossil record, I'd stop here. I'd say, yay, have a party. You know, I mean, the fossil record is demonstrating evolution. I needn't look further. I needn't examine the creation any further, because it's a slam dunk. Evolution is true. But because, I would suggest, a person believes the Bible is true, they're going to say, I'm not happy with that. Go on, and actually allows you to generate a theory, a scientific theory that explains far more than evolution. It explains everything evolution explains, plus a whole bunch more that evolution cannot explain.